Hey everybody, this is Larry. This is day 5 of the Leetcode Daily Challenge. Hit the like button and subscribe on Drop me on Discord. Let me know what you think about today's poem. Yeah, I did, I did a lot of drone shots. Here's some flamencos for you from in the start. Hope you enjoyed, I guess. Yeah, let's take a look at today's poem. These are, I would say these are flamingos from northern Chile in the salt flats area of Atacama. Hopefully I'm saying that right. If not, then Google it, I suppose. But yeah, all right, let's take a look at today's problem of 1975, maximum matrix sum. You're given an n by n matrix. You're given, or you can do the following operations any number of times. Two adjacent elements of matrix and multiply them by -1. It goes to maximize the summation of the matrix element. Return the maximum sum. Okay, so you're able to take two adjacent elements and multiply them -1. Okay. And they're not just -1, but you can multiply by them -1. I mean, the key observation, and I don't. I mean, this was a contest problem, I think, and you have to. I don't know if this is. I'm thinking of a similar problem or not, but actually, it turns out you can choose any two, right? And the reason why you can choose any two is that the visualization that I use is that the visualization that I use is just that. Okay, I mean, it's almost like a blob, right? So maybe I'll draw it out. Hang on. But once you realize that, the actual implementation is pretty easy and interesting. But yeah, but the key observation is that, okay, so, oops. So let's say you have a matrix, right? It doesn't really matter, but you choose, like, say, you start with these two, right? And then now, well, you can just choose these two, right? And then now you can choose these two. But what does that mean? That means that, well, for example, here you chose it twice, so it's -1 twice, which is, by identity. Same thing here. But then what you're left with? You're left with basically this one and this one. And you can do this for any two cells, right? You could kind of, quote unquote, walk this cell anywhere you like to just another cell. And then once you find two cells that you like, and you can like cells in a very greedy way, just choose the maximum negative, then now you do it again with another two. So that's kind of the idea. And once you spot that idea, then we can just play around with it, right? So maybe I have something like this. Maybe for row in matrix, we extend it, right? So we sort it, and maybe you could do this in a cleaner way, but I'm just being lazy, right? So for x, y in, or maybe just like n is equal to right? For I in range of n, right? So and we actually just go to every pairs of numbers, right? So yeah, so if array of I times -1 plus array of I times -1, I guess you can write this differently. So if we flip it, it's equal to us not flipping it. And the reason why I write it this particular way, I'll talk about in a sec. Let me finish typing. Is because there are a lot of different edge cases. For example, maybe once you sort it, you have -5 and a 2. Well, do you flip these? The answer is obviously yes. What about a -2 and a 5? The answer is no. And there are different ways you can represent it, but this should be encompassing to all of them, right? Yeah, basically, if flipping them after sorting gives us a better answer, then we do it. And of course, after sorting, all the negative numbers will be, or the big negative numbers will be in the front, so we could greedy it that way. And then we just return sum of array, and that should be good, unless I made something silly. Well, that's definitely silly. But, alright, whatever. Right, something like that. looks okay for these. Hopefully I didn't make a silly mistake. And yeah, like I did already. But what's complexity here? Query n log n. Can you do better? I don't know. Well, yes, I guess you can do better. You can do it in linear time, right? If you're really careful, but it's just very complex and maybe not very complex, but just more complex and annoying. In fact, as an upsolve, I urge you to try to do it in linear time, right? And linear space. It's not impossible. And if you don't know how, well, pause. If you want to find it by yourself, but you want to know how to do it in linear time, well, all that matters is the negative numbers, and at most, one negative number doesn't matter, right? Maybe there's some stuff about like the smallest positive number as well, but you can play around the edge cases now that you get the idea, because then you don't need to sort, right? Sorting makes it n log n. If you don't do sorting, then it makes it a lot easier, or complexity-wise simpler, right? That's it. That's all I have with this one. Let me know what you think. Thanks for watching, and yeah, stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.